All right, so chapter 14, as it says, is how to work with control structures, exceptions, and regular expressions. Well, with control structures, you've already worked with ifs, you've worked with while loops, you've worked with for loops, and because they insist on doing this, you've worked with do while loops. All right? Now, what they're going to discuss in here is how you can prematurely break out of things using break or continue. All right? How you can use the switch and how you can use the conditional operator. So I'm going to start this very quickly by just doing it a little bit different. I'm going to come in here and I'm going to put in this. So make it nice and big so everybody can see it. So I'm going to say let, let's see, LCV equal 0, while LCV less than or equal to 10. We're going to say, we're going to make a string in here too. Let str equals nothing. All right. So while this is less than that, we're going to say str plus equals LCV, and we're just going to put a blank space between it. Now I'm asking you this question, and please, if I'm mistaken here, let me know. I got one more line to write. So alert LCV. When you look at this, does this make sense to everyone that this is going to print out 0 space, 1 space, 2 space, all the way to 10? Does that make sense? All right, good. All right. What if for some reason, don't ask me why, because I don't know why. What if for some reason I wanted this to stop at 7? Are you with me? What if I wanted it to stop at 7? Well, the easiest way would be to make that 7. I get that. But if I don't want to do that, I can also do this. All right? I can come in here and I can say if LCV equal 7, and I can tell it then to break. So that's going to print out 0, 1, 2, 3, 4, 5, 6, and it's going to stop, and that's what's going to end up alerting in here. Does that make sense to everyone? So break allows you to prematurely get out of a control structure. Usually it's used with loops, and it's not used with like an if, but it is used. You're going to see it in a couple minutes when we talk about using a switch. All right? Does that make sense to everybody? If I replace this, so again, without this, this is going to alert 0 space, 1 space, 2 space, 3 space, 4 space, 5 space, 6 space, 7 space, 8 space, 9 space. Oops, that was good. Try that again and do it human-like. 1 space, 2 space, 3 space, 4 space, 5 space, 6 space, 7 space, 8 space, 9 space, 10 space. You all said you got that. All right, doing it this second way, it's now going to print out 0 space, 1 space, 2 space, 3 space, 4 space, 5 space, 6 space. And that's it. Does all that make sense? If I replace the word break, and I'm just going to comment it out for right now, if I replace that with the word continue, what continue does is it says, okay, skip everything else that's in here and go back up to the next line. I'm going to have a problem then because I'm going to be skipping this. So probably if I was going to use a continue, that instead of doing it like this, I probably would have come in and done this. I would have said for LCV equals 0, LCV less than or equal to 10, plus LCV. All right, then I don't need this line right here. All right, but what I want you to understand is if I use the word continue, then what prints out is 0 space, 1 space, 2 space, 3 space, 4 space, 5 space, 6 space, 8 space, 9 space, 10 space. So continue skips the rest of the loop iteration. So it skips what's down here. It hits continue and it says go back up to the next one. So it adds 1, and it says, well, it's 8, so I want to keep going. It's not 7 anymore, so it just does this. Does that make sense to everybody? Break is used much more often than continue. But if you do have, if a certain type of condition, quite often it's an error type of condition. So if some kind of an error condition arises, this is one way that you can handle it. All right? And I want to show you two more things. First one is this. If I came through here, and again, the examples I'm giving you are purposely simplistic. Num1 equals 23, and I'm going to let, num2 is going to be equal to 18, and I'm going to say let max, I'm not even going to give it a number. Now, you may remember from the last chapter, there's a math.max and a math.min. We could use that and figure out what the smallest number was. We could do that. But I want to show you two other ways of doing it. You already know one of them. I could say, so I can come down here if I want to. So just imagine I'm going to put dot, dot, dot here, which just means there's some code in there. I don't care what it is. But there's some other code. And I'm down here and I'm going to say if num1 is greater than, let's say greater than or equal to num2, max equals num1, else max equals num2. Now, does that make sense to everybody? That's pretty simple stuff, right? All right, I'm going to rewrite that in one line of code. One line of code. All right? And I'll leave this one up here, but I'll put this one above it. So I'm going to say max equals, and I have to check num1 greater than or equal to number 2, and then I say question mark num1 colon num2. This is called the ternary operator. Most operators that we deal with are binary. Something plus something, something minus something, etc. It has one operator, plus, minus, divide, multiply, modulo, etc. But it has two operands, so it's got one thing on each side of it. This is a ternary operator. There are 1, 2, 3 different operands in it. And it means exactly what I showed you down below. It says if number 1 is greater than or equal to number 2, this is the true action. So this says take num1 and assign it to max. This is the false action. And it says take num2 and assign it to max. Does that make sense? All right. I mean, literally, I was at where I used to work in Wisconsin. Every year we got together for 2 or 3 days up in northern Wisconsin in March, which was one of the dumbest things I'd ever seen. But, you know, sometimes we went up there in the middle of snowstorms. But we went up there and we had a half an hour long discussion on whether or not this should be used and who uses it. And one guy said he uses it all the time. And he had actually what I thought was a pretty good reason for using it. And that was, did you ever see like where you want to say the number, you know, when you want to say page as opposed to pages, and you only use the word page singular if it's 1, otherwise you use the word pages. So over here he would have had page, and for the false action he would have had, or this would have been pages, and that would have been page. A lot of people really like this operator. You can see it's replacing 1, 2, 3, 4, 5 lines of code with 1 line of code. And to make it even worse, in this false action, you could put another one of these in there if you want to. And I see people write like that. You may or may not have heard of this term, but there's a lot of languages that allow you to create what are called macros. And with a macro, what you do is you try to take something that's real big and make it real small. You embed the logic inside of it. All right. That's another thing that you can do. All right. I'm going to show you one more, and then we're going to take a break. So that we may run a minute or two over, but I'm going to say here, let size equal, and I'm going to do it like that. Okay. And I'm going to say if size equal. So again, there's going to be some code here. And that's going to ask you your size. Okay, so there'll be some code in there that will, we could have done a parse, not even a parse. We could have done a prompt statement that said, enter your size, small, medium, or large type of thing. Okay, so we're going to say here, if it's equal to, and we're going to suppose you're smart enough that you can put it in capital letters. We could run the 2 uppercase on it. That's fine. So I'm going to say in here, alert, your size is small. All right. Else, if, okay, I got to put a curly brace here. We're just going to assume 3 sizes because I don't want to have to write this much. If your size is medium, we're going to say your size is medium. And we'll just put an else down there. In fact, we'll put an else if. And we'll say this. Else if your size is a large, then it's a large. And I'm just going to come down here and say else. And we'll put an alert in here that just says unknown size. Am I right in assuming that that makes sense to everybody in here? So again, I could have come in here and I could have said here size equal prompt. Please enter small, medium, or large now. Something like that. And then defaulted it, let's say, to medium. Okay? All right. There's absolutely nothing wrong with that code. It works just fine. Okay? But if there's just a few values like this that you're doing, I'm going to show you another way that you could write this. Okay? So I could come in here and say switch size. And I put a curly brace in to start it and a curly brace at the end. And I put in here what are called cases. So case S. Grab my alert here. Break. Case M. And finally, case L. And what you can have in here, what's called a default. It's like your final else. And I'm just going to put what we said before, unknown size. So when you look at this, you might say, I like this one, it's a lot less code. I get that. But you find in a lot of production code that people write it like this. All right? And let's say that I had small and I also had extra small. Okay? But either way, you're a small. So I could come in here and say, put another one in here that said case XS. So I can make as many of those as I want. So now if I either enter S or XS here, it's going to say your size is small. Break says, get the hell out of this loop. Okay? If you don't put break in there, let's say that I enter an S and I don't have any of these breaks. Are you with me? You're going to get an alert that says your size is small, then another alert that says your size is medium, then another alert that says your size is large, then another alert that says unknown size. Everybody does it. You forget to put your break statements in. All right? But as soon as it finds one that matches, it does it, and if it hits the break, it gets out of there. All right? I'm going to take this out because you probably wouldn't normally do it this way. Now, let's assume, remember when we did that program with grades, and like 88 to 100, etc. was an A? That won't work in here. There are programming languages. For example, VisualBasic.net lets you come in here and put in ranges. JavaScript does not. C# does not. So if I wanted to say 88 or 89 or 90 or 91 all the way to 100 was an A, I'd have to make a case 88, case 89, case 90, etc. So when you're working with ranges in most of these languages, you never use a switch statement. However, when you've got just a few values like this, it can make your code much easier to read. Maybe a little more bloated, but it can make it easier to read. Because imagine that instead of just those sizes, all right, like this, let's say that you had 15 sizes. Now you've got this big if with an if with 13 else ifs, then at the bottom you got an else. All right? And a couple last things because we're breaking right now. First of all, with the default, it's not mandatory you put a break there because it's at the bottom anyway, but most people just do. All right? And you don't have to have a default. So if I did not have this default, if I didn't have this, and somebody up here entered hello, nothing would happen. Does that make sense? So it is 9, but we have now talked about virtually everything that's in this section, so I'm going to go through it quickly. All right? Then after the break, we'll look at this invoice. We'll look at exceptions. I'll show you another example. We'll look at regular expressions, but we're going to look at those in more depth and breadth of coverage tomorrow. All right, when we get the code example. All right? So let's take a break. I'm going to pause the video right now. It's 9 o'clock. I'm going to give you 15. So let's come back at 9:15, please. All right, it's a little bit early, but I just want to make sure everybody hears this. This is, a while back I gave you the schedule, and if you look at what's in gray there, tomorrow your Chapter 3 homework, Chapters 2 and 3 from the JavaScript book, your homework, your labs, and your written tests are due. All right, I am going to grade on Sunday, look through everything. A couple of you have given me flash drives because we've had issues and all that stuff. You'll get your flash drives back on Monday, but I hope to have everything graded. What I hate, and I don't think you guys are going to do this, but I've had situations in the past where, I've got a class of 10, 12, 15 people, and it's the end of the semester, and half the class the last day gives me most of their work. That doesn't work well for me because I've got to grade it real fast. Got to figure out, well, you turn it in this late, so how much do I take off? And I got to have grades in. I mean, you guys are done. It's your last day is going to be next month already. Your last day, I believe, is the 17th. I have to have grades in by noon on the 18th. Plus, there's these things that are called outcomes assessments where we've got to write up what we did. All that stuff is due by then. And it's like there's no exceptions. They don't say, hey, well, try to get it done. No. Literally, I had Mr. Corrigan for 1 year when I turned my stuff in. For some reason, I didn't turn in one thing. I forgot to. And it was the next day, I was at home. In fact, I was at Walmart. He was on the phone. He was trying not to get mad at me, but I could tell he was kind of upset. So I had to leave Walmart. I left all my cart there and everything else, went home and did that stuff. So I'm just telling you, I want to have stuff graded. I think it's nice, too, that if the only thing I need from you really in the last day is maybe your portfolio, then I can look at those. If I look at 8 portfolios and I spend 15 to 30 minutes on each one, that's not bad. And then I can figure out your final grade. You should be able to look then on the 18th of December, and your final grade should be out there. All right? Okay. If you are one of the people who hasn't finished yet, like with the Arrow Bridge or any other work, I'll take work. I will give you some credit. How much credit? I don't know. Some of you might be disappointed if you looked at, because if you did turn in your Arrow Bridge, I think 4 out of the 8 of you did, they're graded. But with some of them, if you didn't put much in there, that was reflected in your grade. All right? Any of that need more explanation? Okay. And next week, I'm going to tell you the same thing. It's just that next week, it's going to be 4 and 5. All right? Yeah, and I don't think we're going to have the hands-on. We're pretty much sticking to this. All right? But I don't think we're going to have the hands-on next Friday. We'll probably push it off till the next Monday. All right. I resent you. I'd sent you this earlier, but I resent you this. Where is it? And it's got, so these are both the Mozilla and the W3 schools for numbers, for strings, for dates. That's the last chapter we went over. And this is control structures. So notice if, switch, for loop, while loop, break, and continues in there with break. We're going to talk about exceptions in here and regular expressions. Those are there. And we'll talk a little bit about arrays. Those are there. The other thing is up on the top. I mentioned this to you before. This is that Hunlock site. It's up there with the ugliest sites I've ever seen in my life. Okay. That said, it's so good. Except it hasn't been kept up for about 4 or 5 years. So, you know, with some of the array stuff that's in here, for example, they don't have the newest array stuff that's been added. Does that make sense? Because the site isn't active anymore. But man, if you want to learn JavaScript, this is a great site to go through their tutorial. Okay, and again, they've even got a thing in here with Ajax, which we're going to cover when we talk about the DOM, and don't even worry about what it is. But again, notice, a whole tutorial, numbers, strings, arrays, functions, JSON, which is more what we cover that a little bit in here, but it's more in the fall semester, dates, and Ajax for newbies, you know. So if it's worth your time, take a look at it. If you think, no, it's not worth my time, or I don't have the time, or whatever, then don't. You're not hurting my feelings any. All right. So let's jump into the chapter then. Okay. First of all, by now, you should all understand the difference between these two things. Double equals is equality. Triple equals is equality and identity. So not only do they have to have the same value, but they have to be the same data type. All right, again, if you use the double equals with double quote 5, double quote, and 5 without quotes, it comes back as true. If you do it with triple quotes, it comes back with false. All right, I don't think there's really anything more to say about it. The break statement I went over with you, the continue statement I went over with you already, so I'm not going to run over those again. The switch statement I just went over with you. You like theirs better than mine? Cool. But you can see it's pretty much the same thing in here. It used to be in almost all programming languages, what you put in here, this case, you know, etc., whatever you put in there, that had to be a whole number. You couldn't put a string in there like this, like I showed you. That's changed over the last few years. It's so much nicer with these. Now, again, is that a great example? It's a good example, and it shows you it's pretty much what I showed you. But it could have been done using an if. You could have gone back and rewritten the whole thing with an if rather. If you just want to say past, again, we could have said here case A, and then underneath it case B, and then underneath that case C, and we could have said, you know, average or above, you pass. And then for D or F, we could have said average, you know, below average, you fail. All right, and then we could have left the default in here, and that's kind of what they're showing in here. So here they're assuming if you get an A or a B, you can get a scholarship. Okay? But again, I tried to go over an example that was simple enough that it would make sense to you, but good enough that it would at least show you the principles that were in there. All right? This is that conditional operator. You'll hear it called the conditional operator. You'll hear it called the ternary operator because it's the only one, again, with 3 things. And you'll hear it called the question mark colon operator. Depends on the book you read. It's really not that big a thing one way or the other. All right? And they give you an example. It's not that different from the ones that I've given you. Then they show you how you could rewrite it using an if. That's what I did. All right. How to use and ors. The key thing when working with and ors, and I probably have said this to you before, but just in case I have not, all right, and that is that's the order. Unless you use parentheses to change the default order, you do nots first, you do and second, and you do ors third. That's the most restrictive to the least restrictive. And by now you should know that for not, it's an exclamation point. For and, it's a double ampersand. For or, it's a double pipe sign. Any questions on that? I mean, we have hit on that stuff before. The good news is it's like that for C#. It's like that for Java. So there's not a lot of relearning that you have to do. Some languages literally allow you to use the words and or, which is nice because it makes your code a little bit more readable. All right, especially for those people who don't know what those symbols mean. All right. And again, not and or, but if you want to change that, you use parentheses, right? We talked about that too. So they've got this invoice application in here that looks like this. And the idea is there's a drop-down list here where it's got honored citizen, some other stuff. I don't care. And you've got an invoice total. When you click calculate, it gives you some kind of a discount depending on what you chose up here. Does that make sense? All right. And it shows you the percentage that you get, the amount of the discount that you get. Then it subtracts the discount from the subtotal, and it gives you your invoice total. Does all that make sense? All right. I'm not saying it's a good example or a bad example. It's an example. It's fine. All right. Again, you can see where the IDs are in here. And if we look at the JavaScript, again, a little bit more, maybe 50 lines. But with the stuff that you've learned today, again, the only thing that we haven't gone over is this, which we'll go over in a couple weeks, which just means don't run this until the document has been loaded into memory. It allows us to use jQuery. All right. But other than that, you should be able to look at the rest of the stuff that's in here, and ideally, at least, it makes sense to you. All right. That's just a regular function. We've written these kinds of things before, but not with a switch statement in there. Here's another one. So notice this says if you've got an ID of calculate and you click that, this is what you want to run. Again, ours weren't done exactly like that. We registered ours first, but there's always more than one way of doing the same thing. All right. It used to say that old saying, there's more than one way to skin a cat. And one year I had a student come up to me telling me they had a bunch of cats and could I please not use that expression anymore. So when I can, I try not to. All right. All right. The last thing that's in there, that's in this chapter, are how to handle exceptions. So I'm going to go back to here again. I'm going to remove this, and I'm going to type in this. I'm making this up, so don't key it in, and it doesn't mean anything. Okay. I'm going to come up here and I'm going to say this. Let's see. Let number equal prompt. Enter a number, a whole number. All right, I'm going to cut this down a little bit in size because I want to say parse int. Okay, and I'll give it a default of 3. 3 has no special meaning, but just so you see that. All right. So there's that. So I'm going to come in here and I'm going to say if number modulo 2 equal 0. You've seen this before. We're going to say alert the number. We'll use our old backticks. Backtick. The number is even. Else if number modulo 2, I know I'm writing it a little different than I have in the past. I'm doing it on purpose. And grab this. Now I'm going to say the number is odd. All right, and I'm going to leave it right there. All right, and I'm going to end this, and I'm going to type in catch exception, and I'm going to say alert a non-numeric input was entered. Now, in the past, what we've always done is we've checked for is NaN, which is totally fine to do. But I'm showing you here another way of doing this, because what you'll find is a lot of times in code, what you put inside of what's called a try block, and it's called a block because it's inside of curly braces and it starts with the word try. is you put in one or more lines of code that could conceivably fail. Are you with me? They could fail. If they fail, then this runs. The catch runs. And I'm making this purposely really simplistic because you can have all sorts of different kinds of exceptions. C#, for example, must have 30 or 40 different exceptions that you can have. Number out of range, non-numeric, if you're working with a file, file not found, etc. There's a lot of different types of exceptions. So what you put in a try block is code that could conceivably fail. If everything in here works, if I put in 37, it says the number 37 is odd, correct? And it totally skips this. If I put in 54, it'll say the number 54 is even, and it totally skips this. If I leave it blank or put in hello, well, that isn't true, and that isn't true. All right, and the other thing I can do is I can say else here, throw exception. And I've said this kind of thing to you before. An exception in a programming language is a bad thing. It's an exception to the rule. So this will throw an exception, which means that should print. So when you have a try-catch block, in the try block, you put in code that can conceivably fail. If that code does not fail, you totally skip the catch block. If you've got 10 lines in there and you end on line 3, you get an error, it immediately goes to the catch and it skips the rest of the stuff in the try. You can't go back to it. You can't like use a goto and tell it to go back again. All right? So that's how these things work. There's also something that you can put in, but you don't have to. It's called a finally block. So if I put in here finally and I put down alert end of program run. Finally runs whether the try succeeded and you skipped the catch, or there was an error in the try and you did the catch. The finally always runs. Typically you use a finally, and we're not nearly there yet, if you wanted to work with a database. And let's say that I wanted to work with a database and there was a problem with the database. I was working with it, now there's a problem with the database. I want to close that database when I get done with it so someone else can use it. So you use a finally block typically, not like I've used it, but you use it for what are called housekeeping operations, to close something that was open or whatever. All right, so with that in mind, let's go look at what they say in here. So again, to handle exceptions in JavaScript, you use a try-catch as shown in the figure. Well, that's pretty much what I just showed you. So they've gone back to this calculate future value thing, and notice what they put in here. All right, so it says var future value equal investment, so you're passing in some kind of an investment, etc. And we are catching an error in here. Now, if you notice this, it says catch error. That actually is the error itself. I didn't show that, but you can do that. And then this will give you the name of the error and the text that goes along with that error, if you get that. All right. You can say catch, you can put your own message in, you can put in system stuff, etc. But I want to go over this because this is probably all that we're gonna use this semester. So I just at least want you to be exposed to it. In fall of next year, with some of the stuff that you do in Node.js, it requires that you use a try-catch statement. So the reason I'm telling you that is you're going to see this again. Plus, there is a try-catch that's in C#, and it's done virtually the same way as this. There's a try-catch that you can use in JavaScript, in Java rather, and it's done virtually this way. All right. So it says you can use the try-catch to process any errors that are thrown by an application. The errors are referred to as exceptions, and the process is known as exception handling. It's even more complex than that because there's different kinds of exceptions. Some of those exceptions you can handle, and some of those exceptions you can't handle. Okay, for example, if you're telling the user, if you have in your program that you want to read an image file and you want to display it on your web page, well, if the image file doesn't exist, you can let the user know it's not there, and if you've got that alt tag, you can display that, and that's fine. But what if, for some reason, what if you run out of memory on your computer? There's probably not much you can do with that. I mean, your JavaScript program can't do that. You can't handle that. So there's certain exceptions that you cannot physically handle in your program. All right? Okay. So it says in a try-catch, you code the try block that contains the statements that may fail or may throw exceptions. Then you code a catch block, and you can have multiple catch blocks because you can look for a bunch of different things happening. If you look for a bunch of different things happening, they actually have what's called a hierarchy. You've got to put the most specific thing first and the least specific thing last, all right, or the most general thing last. It says then you code a catch block that contains the statements that are executed when the exception is thrown. So in other words, instead of your program breaking right there, you can try to recover from it or at least end the program gracefully. All right? So again, I showed you that optional finally block, and as mentioned, it's executed whether the try succeeds and there's no catch, or whether the try fails and the catch is executed. All right? And again, the error name variable in the catch block gives you access to the error object that has the type and the message, as they showed right there. All right. I already told you this, and I showed you this in the example. It wasn't a great example. Right there, that's you throwing your own error. Why? Because there's only a certain number of these errors that actually exist. For instance, there's not a built-in error in JavaScript that says you didn't enter a miles per gallon that was a whole number. Does that make sense? There's no built-in JavaScript error for that. But you could throw your own error that said that. And then you could catch it in your program if you wanted to do that. Now, with the stuff that we've done using ifs, like we're using them, that's a lot of people handle some of their errors that way. But with some errors and some of the stuff that you do in some languages will require that you do it this way. Or sometimes you might have a choice, but it may actually make more sense to do it this way. All right? So here's some of the error types. Range error. Remember in the miles per gallon program, we said that you had to drive between 1 and 100 or 1 and 1,000 miles. We could set that if it was out of range. We could throw a range error. All right. We also said that the gallons used were like between 1 and whatever it was, 10 or whatever the heck it was, 1 and 100. Could do that. All right. There's a reference error. A variable is read which hasn't been defined. So I say let age, and I don't give age an initial value, and I try to use it in the program before I give it a value. So it's undefined. You get a reference error. A syntax error. Those typically you don't have to worry about because usually with your syntax, the interpreter will find that anyway. All right. And a type error. The type of value is different than what was expected. That can be used, for example, if you're expecting something numeric and you put in something non-numeric. There's a list. These are just, as it says, some. This is not an exhaustive list. All right. Why would you have these? Why would you use this? Okay, it says, why would you try to throw your own error? Well, if you want to make sure that maybe it's never getting called, maybe the try is always working. So you want to introduce something artificial in while you're testing to make it actually fail. All right, to make sure that your catch is working correctly. That's typically the reason that you'll do that. All right. It says to trigger a runtime error, you will use the throw statement. You throw things. Singular, T-H-R-O-W. The programming language throws things with an S on the end. It may sound simple, but if you see a throws with an S on it, it's coming from the system. If you see a throw, it's assuming you did it. And why is that significant? Because if you did it, you better handle it. Okay. All right, and the last thing that's discussed in this chapter is regular expressions. Now, we could go off and we could do a lot of stuff on regular expressions. What I'm going to do tomorrow is I'm going to show you the same form, and I'm going to have it in there twice. And the first time we're going to see how much form validation we can do just using HTML5. Then we'll go back and we'll rewrite that, and you'll have the code already, but we'll write it just using what's called vanilla JavaScript. It's called vanilla because it means that there's no jQuery in it, there's nothing special in it. It's just the stuff that's built into JavaScript itself. All right? So we'll look at this stuff tomorrow is what I'm telling you. But a regular expression, what you're doing is, so let's say that I wanted to go through and I had something in there, and it's kind of like looking for substrings. I've got a whole bunch of stuff, and let's say, for example, I got a phone number. And I say that you've got to put a phone number in the format. So my phone number here, it would have to be 38, I always forget what it is, 314-286-3675. You couldn't put it in parens with the area code, etc. You couldn't put it in without, just all the numbers. You'd have to put it in that way. So you could use what's called a regular expression pattern to make sure they put it in that way. And if they didn't, you just wouldn't accept it. That's what we're going to look at tomorrow. All right. You can set up regular expression patterns for a lot of different things. I actually showed you this a while back, but there's html5pattern.com, which isn't bad. So for instance, if I go to phones here and I want a phone number to be in a certain way, there's a US phone number. It looks kind of ugly, but notice if I do put in 111-22-3333 and I test it, it says it passed. If I do it again and I try doing it and say it like this, like that, it says please match the required, what you're looking for. And again, I don't expect this to make a boatload of sense to you, but the D here means digits, 3 digits, followed by a hyphen, followed by 3 digits, followed by a hyphen, followed by 4 digits. Make sense? There's other ways you can write it other than this as well. All right? Oops. And there's different characters you can match. Okay? We'll look at some of this stuff tomorrow. Okay? And this means that the pattern starts with something. If you put a caret at the beginning, it ends with, that's the $sign at the end. All right? I don't expect for all of that to make a boatload of sense to you. But here's some examples. All right? So they've got a lot of them with phone numbers and zip codes. And remember, with zip codes, 5 digits or 5 digits hyphen and 4 digits. So notice how this is put in parentheses right here, which means it's optional. All right? But if you put in 5 digits, a hyphen and 3 digits, it would fail because it's expecting 4 digits. All right? And finally, they have this account profile application. This is similar to things we've already looked at, but they're verifying that the email is valid, that the phone number is in the right format, that the zip code is in the right format, and that the date of birth is in a month. So all of them have failed. All right, so why? Well, this failed because there's no .com or .whatever on the end. This failed because the last 3 digits should be 4 digits. This failed because the zip code has only 4 digits. And this failed because there's no month 15. All right? So you can see when you start writing this, when we go over now and look at the JavaScript, it'll be lengthier. Here's a pattern that we're using for a date. There's different ways you can do this. And with some of this, I don't know how well they did it in here because I didn't look at the example, but they'll make sure that you're putting in a month that's between 1 and 12, because if you don't, it won't take it. But here it says if day is greater than 31. That's not a very good check. That says you could put negative numbers in, you could put 0 in, and for November that we're in right now, you could put the 31st. So if you want to cover all that stuff, well, what's one way you could do it? Guess what? You could write a switch statement. And you could say that for January, March, May, July, August, October, and December, that you would allow 31 days as the max. And other than the screwy month of February, and all the other months, the other 4, you would say 30 days. In February, you'd have to even make a leap year check. All make sense? So again, some of this stuff can get fairly lengthy when you start putting that in. All right, and that's it for that chapter. All right. Now, I didn't send it to you today, but I am going to end up sending you another